Well, good morning, everyone. Here we are on another wonderful Friday, ready to do some heavy duty math and research. Today, I want to talk about satellites or cell phone towers. How do we get our digital TV? I know if you've been around a while, you hear flat earthers saying there's no such thing as satellites. We get all of our so-called digital TV from cell phone towers. So I wanted to look at that to see if that's true. Here's a little overview. To get a satellite dish aligned correctly, you must maximize the signal on 3 planes. So if you look at this diagram up here, oops, you can't see it. Oh, there we go. This is the left, right, like this, which is east and west, or azimuth. Then the second one is the elevation angle, which is up and down for the dish, like this. And the last one is the skew adjustment, which is the angle that the LNB, which is that little device right there, that little thing, the angle which that is fixed into the LNB holder. So this thing can be adjusted up and down. I got that information from this website. And then geosynchronous satellites, the type used for TV broadcasting, all orbit at the equator at an altitude of about 22,500 miles. At that altitude, orbital velocity will allow the satellite to hover over one spot on the Earth. So, geosynchronous satellites, the way they're set in their orbit, at the altitude and the orbital speed, they stay over one location on the Earth. At that altitude, orbital velocity allows the satellite to hover over one spot. Let's assume you live north of the equator. Sorry about that, anti-flatter. We're going to do north of the equator. All geosynchronous satellites will be to your south. On the east coast, satellite dishes will probably be pointed southwest. The ideal orbit for a geosynchronous satellite that will cover the entire United States would be over the Pacific Ocean, west of Ecuador, where a line of longitude passes through Kansas City and crosses the equator. However, this is a crowded orbit, so you might have to look east or west of this spot. So here's some maps of my personal location. This is my satellite dish. First of all, if you look over here, the latitude and longitude of my city, 35 degrees north, 107 degrees west. And then they convert that to degrees and minutes. And this calculates that it's pointed to satellite 110.1 west orbital longitude. So 110.1 is the longitude of this satellite. And then the dish elevation, azimuth, polarization, most of these numbers, I don't know what they mean. For polar mounts only, the main angle is 36.0 degrees. This is the angle that my satellite is set to, 36.0 degrees. And again, the satellite is 110.1 west. So remember this 36 degrees. Here is just a list of satellites. I wanted to show you how many there were. This is only for Dish Network. So there are 17 of these satellites, and these are only used by Dish Network. So DirecTV and whatever these other digital networks use different satellites. So you can tell that there's a whole bunch of them up there. You might also notice I looked on my Dish box. There's a way you can check the setup, and it says that I use this 110.1 satellite. So I thought that was pretty interesting because that's what the calculator said as well. Here are some pictures from my location. Everybody can see that this time of year everything's kind of brown. This tree looking thing right there, that real dark green, the taller one, that's a satellite tower. It's been disguised as a tree. I measured, it's 1.5 miles from my house. And then this is a picture of my personal satellite dish, and you can see that it's angled at about 36 degrees. I did do measurements of about 10 other satellite dishes, and I got more or less the same angle on those. So this is the last thing. We're going to do some calculations just to see which one is more likely, the cell tower or the satellite. If you remember from good old geometry or trigonometry, we have a right triangle, an angle over here, the adjacent side, and the opposite side. You remember that, everybody? So the tangent of that angle right there, is equal to the opposite side, y, divided by the adjacent side, x. I calculated the tangent of that angle is 7.75. So for the cell phone tower, if you multiply this out, this altitude right here, the opposite, is 1.5 miles. That's how many miles away from my house, that's x, times 7.75, which is that tangent. That gives me 11.63 miles high. So at 1.5 miles from my house, that satellite tower has to be almost 12 miles tall in order for the signal to reach my dish. Okay? So keep that in mind. Does that sound reasonable? You saw the picture of the closest cell tower to my house. I don't think it looks 12 miles high. The other calculation I did, same right triangle, is for the satellite. And you remember that my distance was 3649 kilometers, which happens to be 2,451 miles, times the tangent of that angle, 7.75, gives me height or an altitude of 18,995. And if you recall on one of the first slides, he said that the geosynchronous satellites were in an orbit of 22,500 miles high. And so I think this is a pretty good estimate, pretty close. You remember that it said the latitude, longitude had some error to it, and my calculations had some error because of the map. So I don't expect it to be exactly 22,500. And sure enough, it was close, but not quite. So I think we've definitely proven that it cannot be the cell phone tower. There's just no way the cell phone tower is 12 miles high. So it has to be the satellite. And you can see the distance there. So I hope you all learned something from this lesson. I certainly did. I must say thank you to the Flat Earthers, because I sure learn a lot from researching these videos. We'll see you next week. I hope you have a good weekend.